Today our group will present about transformer protection scheme. Okay, first, overview of the power transformer. A power transformer is a static machine used for transforming power from one circuit to another without changing frequency. Okay, the very basic of the transformer is there are no rotating or moving part, so transformer is a static device. Transformer operates on AC supplies. A transformer also works on the principle of mutual induction. Okay, second for the topic is transformer protection. Okay, there are a few different kinds of transformer, such as 2 windings or 3 windings electric power transformation, auto transformer, regulating transformer, and earthing transformer, also rectifier transformer, and so on. Okay, different transformer demand different schemes of transformer protection, depends upon their importance. Okay, this is a structure of the transformer. There is a oil level indicator, gas detector, relay, OLTC, OP, gear and supervisor, oil and winding thermometers, cooling supervisors, motor starters, and pressure relief valves. Next on the nature of transformer faults. Okay, there are 4 faults that we recognize. First is overcurrent due to overloads and accidental short circuits, and second, terminal faults. Okay, terminal faults is a small amount of decomposition occurs at normal operating temperatures. As the fault temperature rises, the formation of the degradation gases change from methanol to ethanol to acetanol. A terminal fault at low temperature produce mainly methanol and ethanol and some of acetanol. Okay, for the third fault is winding faults. Okay, in the winding faults, it depends on source impedance, neutral earthing impedance, also transformer leakage, reactance, and fault voltage and winding connection. Okay, for the fourth fault is inception fault. Okay, in the inception faults, internal faults which constitute no immediate hazard. But if we not take care of these faults early, this will be a major fault to the transformer. Okay, for magnetizing inrush current in the transformer. Okay, first, the transformer inrush current is the maximum instantaneous current drawn by the primary of the transformer. When their secondary is open circuit, the inrush current doesn't create any permanent permanent fault, but it causes an unwanted switching in the circuit breaker of the transformer. During the inrush current, the maximum value and 10 by the fault in over twice the normal flux. Okay, that's all for me. I will give to
The system and principle of protection scheme for transformer. Transformer overcurrent protection. Fuse commonly protect the small distribution transformer, typically up to rating of 1 MW at a distribution voltage. The fuse must have a rating well above the maximum transformer load current to withstand the short duration overload that may occur. During this process, the high rupturing capacity is known as HRC fuse, also very fast in operation with large fault current. It are extremely slow with current of less than 3 times their rated value. Overcurrent relay. With the advent of ring main unit incorporating SF6, circuit breaker and isolator, a protection of distribution transformer can be provided by overcurrent trip. Overcurrent relay are also used on a larger transformer provided with standard circuit breaker control. This improvement in protection is obtained in two ways: the excessive delay of the HRC fuse for lower fault current are avoided, and a fault tripping element is provided in addition to the overcurrent feature. This time delay characteristic should be chosen to discriminate with circuit protection on the secondary side. Next topic is restricted or earth fault protection. Conventional earth fault protection using overcurrent element fail to provide adequate protection for a transformer winding. This applies particularly to a star-connected winding with an impedance neutral. For the high impedance type, the residual current of three-line current transformer is balanced against the output of current transformer in the neutral conductor. In the bias low impedance vision, the three-phase current and the neutral current balance become the bias input to a differential element. Next topic is differential protection. Basic consideration for transformer differential protection. It applies in the principle of differential protection to the transformer. A variety of considerations have to be taken into account. Secondly, the line second transformer primary rating. Line current transformer have a primary rating selected to be approximately equal to the rated current of the transformer winding to which are applied. The phase correction operation of transformer differential protection. This requires that the transformer of primary and the secondary current as measured by the relay are in phase. Filtering of zero sequence current is essential to provide some form of zero sequence filtering where a transformer winding can bypass zero sequence current to an external earth fault. Next, ratio correction. A current operation to the differential element requires that the current in the differential element balance under the load and through fault conditions. Next, number 6, the bias setting. Bias is applied to the transformer differential protection for the same reason as the any unit protection scheme. Lastly, number 7, transformer with multiple winding. The unit protection of principle remains valid for a system having more than 2 connections. So a transformer with 3 or more windings can still be protected by the application of the above principle that have been told. And that's all for me. I will pass to my friend for the case study.
Okay, about case study, average 8 in 1000 distribution transformers is expected to fail with 30 of Dewey lightning relate cost. The lightning parameter directly relate to transformers failures are high return stroke peak current, high rate of current rise and multiplies, flashes and positive lightning flashes. Okay, second, with again transformers with reduced insulation strength, lightning flashes accelerate the end of the life failures. Okay, third, lightning flashes to the customer electrical installation impact the transformers straight the secondary winding, as well as lightning current in neutral and secondary circuit. Okay, transformers important cause of transformers failure lead to fire and explosion. Okay, one example case study around the world. While foreigners in India, about 300 electricity transformers were burned to ashes in a major fire at the transformers repair shed at Jetchel town of Mahbubnagar on Sunday morning on 13 May 2013. No one was injured in the midship as it was a holiday. The accident occurred when oil in one of the transformers caught fire, turning the repair shed into a hot fireball within minutes. Okay, one more case study around in Malaysia. What I found is electrical shock and exploding in transformer room. The accident occurred when a worker was loosening the power supply wire to the circuit breaker when accidentally part of 15 body head touched or entered the clearance space of 11 kilovolt ampere power system. As a result, a short circuit and flashover occurred, which resulted in an explosion that injured the workers. Okay, in conclusion, what we learn about this is we know the transformers protection method is very important because transformers are the critical and expensive component of the power system. Transformers failures are expensive and also may be dangerous for personnel. The cost of energy not delivered because of the transformers unavailability and additional cost may be very high. Okay, next, we know how to prevent transformers accident from happening, such as burning or exploding transformers. Okay, about suggestion, we suggestion is plain maintenance, inspection and testing will significantly reduce the number of transformers failures. Okay, that's all for us, and thank you.